Welcome to Mathematics. Today we'll be solving the Pearson Edexcel IAL January 2023 paper of F1. The first question is a question about matrix. In the first part, we have to multiply matrix A and matrix B. So we have matrix AB. So at first I have to determine the dimensions of matrix AB. To do that, I write down the row and column, the dimensions of the matrix we are multiplying. So on the left we have matrix A, so I'll write it over here. On the right we have matrix B, so I'll write it under. Matrix A has 2 rows, and it has 3 columns. So matrix A is a 2-3 matrix. Matrix B has 3 rows and 2 columns. So 3 horizontal rows and 2 vertical columns. Now the matrix multiple is only possible if this value over here, the row of the second one, and the column of the first one are the same. In this case both are 3, so we can multiply A and B. There is a product AB. And the dimensions of AB will be 2, 2. The row of the first one and the column of the second one. So 2 into 2 matrix. AB is a 2 into 2 matrix. Now the matrix multiplication is done in this shape. So 2 will be multiplied by 1, minus 1 will be multiplied with 0, 3 will be multiplied by 2k for this value here. So among the 4 values, this value over here will be 2 into 1 plus minus 1 into 0 plus 3 times 2k. This value over here will be the multiple of 2 and k, minus 1 and minus 3, 3 and 2. So it will come out to be 2k plus 3 plus 6. I can find this one out over here as well. This will be 2 times 1, 2 plus 6k. And the next one is 2k plus 3 plus 6, or 2k plus 9. Now we go down here. This will be minus 2 times 1, so minus 2, 3 times 0, so 0 over here. I'll not write it down, and then 0 multiplied by 2k, so only minus 2 over here. And on the bottom right, I'll multiply minus 2 with k, I get minus 2k. Then I multiply 3 with minus 3, I get minus 9, and finally I have 0 multiplied by 2, so 0. This is the matrix AB. The matrix AB will be 2 plus 6k, 2k plus 9, minus 2, minus 2k minus 9. Now for the next part, we are given we have to find the value of k when the determinant of matrix AB is 0. So for matrix M, which is ABCD, the determinant of this matrix M will be AD minus BC. So the product of these two values minus the product of these two values. So for part B, I have determinant of AB set to 0. The determinant of AB will be of matrix AB will be these two values multiplied. So 2 plus 6k multiplied by minus 2k minus 9 minus the product of these two values. I'll have minus 2 times 2k plus 9, which is 0. Now I'll get a quadratic equation from here. Multiplying this over here, I get 2 times minus 2, which is minus 4k. 2 times minus 9 is minus 18. Then I have 6k times minus 2k, so minus 12k square. And finally I have 6k times minus 9, which is minus 54k. And then I have this term over here. Minus minus 2 is plus 2. So 2 times 2k is 4k, and 2 times 9 is 18. This is 0. This 18 over here and this 18 over here cancel out. I have minus 12k square. Oh, this minus 4k and plus 4k also cancel out. So I have minus 12k square minus 54k. I can multiply minus 1 with this, and I multiply minus 1 with 0, so I'll get 0 back. Multiplying minus 1 on both sides. This will be 12k square minus plus 54k equals to 0. I can take k out as a common. I'll have 12k plus 54 equals to 0. The value of k will be 0, or the value of k will be minus 54 by 12, which is equal to minus 9 by 2. Now we know that k is a non-zero constant. It's given in the question. So k cannot be 0, so we do not take k equals to 0 as a solution. So k must be minus 9 by 2. Now moving on to the second question, we have the summation. We have to use the standard results which are given in the data booklet over here in this equation. I have to show that this equation on the left can be simplified into this form. So I have summation of r equals to 1 to n for 7r minus 5 whole square. I'll break down 7r minus 5 whole square. I'll have 7 square r square, or 7r whole square, minus 2 times 7r times 5 plus 5 square. So I want to find the summation of this whole thing over here. I'll get summation of r equals to 1 to n of 49r square minus 70r plus 25. Now if there's they're in an addition form inside summation, I can separate them. I can separate them like this. So I have the summation of r equals to 1 to n of 49r square. I can write the 49 outside and only have the variable inside. Then I'll have minus 70 times the summation of r equals to 1 to n for r, and then I have the summation of 25 from r equals to 1 to n. The first two are just given in the data booklet. We just have to follow that. Now for this term over here, it's a constant being added n times. So if I had something, for example, like this, so summation of r equals to 1 to 5 of 10, this will basically mean adding 10 5 times. So this is the first term, the second term is also 10, the third term is also 10, the fourth term is also 10, and finally the fifth term is also 10. So I am adding 10 5 times over here, which is 5 into 10 or 50. So if I replace the 5 with an n, I have n times 10 over here, and if I replace the 10 with a 25, I have n multiplied by 25. So the summation of this thing will be 25 times n. The other ones, you have to use the data booklet. If I go there, here is the summation of r square, and for the summation of r, this is basically an arithmetic series. The value of r is 1. For the first term it's 1, for the second term it's 2, for the third term it's 3, for the fourth term it's 4, and so on and so on. So this is basically an arithmetic series. We know the summation of an arithmetic series, which is given in this section under P2, which is this formula over here, where n is the number of terms, a is the first term, l is the last term. So for summation r equals to 1 to n of r, the first term is 1, we go on and on up to getting the last term, which is n. So we can just put in half n times a, which is 1, and l, or the last term, is n. So we have half n times n plus 1. This is the summation of r. And the summation of r square is over here under F1, this formula over here, 1 by 6n times n plus 1 times 2n plus 1. Now coming back here, we can just apply the formulas directly. We have 49 times n by 6 n plus 1 times 2n plus 1. This is for r square. I basically wrote 1 by 6n as n by 6, and then I have minus 70 times half into n times n plus 1, and I add 25n over that. Now I'll keep on simplifying this. The first term is 49 times, I can take 1 by the 6 as the denominator of the whole thing. So I'll have 49n times n plus 1 times 2n plus 1 minus, so the denominator over here is 2, so I have to multiply it with 3 to get 6. So I'll multiply the top with 3 as well, so 17 to 3 times half n times n plus 1. The denominator over here is 1, so I have to multiply the whole thing with 6, so 25 into 6, which is 150 n. Now I can simplify the terms on the top. 49n square plus 49n multiplied by 2n plus 1, basically multiplying this 2 together. Then I have minus 17 to 3 into half, which is 105 n square. I'll do it in the next line, 105n times n plus 1 and 150n at the last. Now if I multiply 49n square with 2n, I get 98n cube. Now if I multiply 49n square with 1, I get 49n square. Then I multiply 49n with 2n, I get 98n square. And finally I get 49n from multiplying 49n with 1. Then I have minus 105n into n, which is minus 105n square. Then I have 105n multiplied by 1, which is minus 105n. And I have a 150n added at the last, all divided by 6. Now from all these terms, there are no constants. The lowest power of n is 1. I can take n out as a common. And inside this, I'll have 98n square. The cube will become squared. The square will become n to the power 1. And the terms with n to the power 1 will become constants inside the bracket. So if I add this all up, the ones with the power of 2, I get 49 plus 98 minus 105, which is, oh my bad in the calculation, this half will also go out, so this will be 210, not 105. So this and this will be 210. Okay, if I continue with the squared, I get 49 plus 98 minus 210. This is minus 63n. Now if I multiply the ones with the power of n, I have my plus 49n minus 210n plus 150n. If I calculate this, this will come out to be minus 11. So this is our term over here, and this is divided by 6. Now I have to show that this is 7n plus 1. So 7n plus 1 is a factor of this thing over here. I can just solve this quadratic function in a calculator and place the values over here. If I do that, I get 11n minus 14 multiplied by 7n plus 1 all divided by 6. So this is the same thing. Here the value of a is 11, the value of b is minus 14. If you want, you can write it in the format they wrote it in. So n by 6 times 7n plus 1 times 11n minus 14. Now moving on to the next question. We have this cubic function over here. In the first question, we are given that minus 3 is a root, and using that we have to find the value of p. So the function for minus 3 is 0. Since minus 3 is a root of the equation, now I'll put the value of z minus 3. So I'll set z to be minus 3 over here. Put in minus 3 instead of z. I'll have 4 times minus 3 cube plus p times minus 3 square minus 24 times minus 3 plus 108. This will be equal to 0 since minus 3 is a factor. 4 times minus 3 cube will be minus 108. P times minus 3 square will be 9p, and minus 24 times minus 3 will be 72. Now this will be 9p equals to minus 72. The value of p will be 8. Sorry, the value of p will be minus 8. Now for part B, we have to solve f of z completely. So I'll just have to use this value with this, and the fact that minus 3 is a solution or a root. X equals to minus 3 is a root of f of z. If I write f of z down right now, since I have the value of p, this will be 4z cube minus 8z square minus 24z plus 108. So I can either use long division over here or the synthetic division. The long division is far more reliable over here, but if you're struggling with time conservation, you can go for the synthetic method as well. Since x equals to minus 3 is a factor or is a root, x plus 3 will be a factor of this equation. So z plus 3 in this case, and I divide 4z cube minus 8z square minus 24z plus 108. I have 4z square over here, 4z cube plus 3 times 4z square is 12z square. I'll subtract this thing over here, so this will be a minus, this will also be a minus, this cancels out. I have minus 8 minus 12z square, so minus 20z square minus 24z. I can now use minus 20z, it will become minus 20z square minus 60z. Once again I'm subtracting the whole thing, so the minus will become a positive, this minus will also become a plus, this cancels out, and minus 24z plus 60z is 36z. 36z plus 108 is remaining. I'll add 36 over here, I'll get 36z, and 3 times 36 is 108, so 36z plus 108, the remainder is 0. So we can write f of z as z plus 3 multiplied by the equation over here, which is 4z square minus 20z plus 36. Now if you want to use the synthetic method, you don't have to know this method, you can skip ahead if you don't want to use this. So I'll write down the terms over here of the equation. So 4 minus 8 minus 24 and 108, and I'll write down the root we are using, minus 3. So if I bring down 4, this is 4 times minus 3 is minus 12, minus 8 minus 12 is minus 20, so 4 minus 20, minus 20 times minus 3 is plus 60, so 60 over here, 60 minus 24 is 36, and 36 times minus 3 is minus 108, 0 is the remainder over here. So from here I find f of z to be z plus 3 for this, and 4z square minus 20z plus 36 from here. Now after I get f of z, I'll factor out, since I have to find the roots, I'll set f of z equals to 0. So this whole thing over here is 0, so z plus 3 times z, 4z square minus 20z plus 36 is 0. Now if you try to factorize this over here, you'll get imaginary roots, so I cannot use middle term over here, I'll use the quadratic formula. So z equals to minus 3 is a root, we know that from beforehand, and for the other roots I'll have z equals to b square, which is minus 20 square plus or minus, sorry, minus 20, so minus b. We'll use this formula. This will be minus 20 square minus 4 times 36 and divided by 2 times 4. I have z equals to 20 plus or minus root over, and inside the root over I'll have 20 square minus 4 into 4 into 36, this is minus 176 by 8. Now I can write down root over minus 176 as 4 root 11 I divided by 8. I can take 4 common in the numerator. I have 4 times 5 plus or minus I root 11 divided by 8. I'll have half. So the other roots are 5 plus or minus I root 11 by 2. So the roots are z equals to minus 3, z equals to 5 plus I root 11 by 2, and z equals to 5 minus I root 11 by 2. Now for part C, we have to find the modulus of the complex roots of f of z equals to 0. So basically the modulus of these two values, since they're conjugate values, they have the same modulus. So for them the modulus will be 5 by 2 square plus root 11 by 2 whole square, and we take the root over of that. This will be 3 over here. Now for part D, we have to show the roots, all 3 roots on an Argand diagram. If I draw that, so I'll draw the axis at first. This is the real axis, the imaginary axis. The real root over here is minus 3. So this is the real root. So from the origin up to here. Now the complex roots will be 5 by 2 plus or minus root 11i. The real value is 5 over here. Draw a line at 5 just for reference in this case, and I'll have root 11 over here minus root 11 over here. These are the two values. These are the other roots. Draw an arrow up to them. So this is 5 plus I root 11 by 2. This is 5 minus I root 11 by 2. Now we'll move to question 4. In the first part of this question, I have to differentiate this function over here. If I differentiate f of x, I'll get, so if I write f of x down before I do that, I have 1 minus 1 by 8 x to the power minus 4 and plus 2 by 7. This is 7 square root of x to the power 7. So x to the power 7 by 2. If I differentiate this, if I differentiate 1, I get 0. If I differentiate this term over here, I'll have minus 1 by 8 x times minus 4 times x to the power minus 5 plus, in this case I have 2 by 7 multiplied by 7 by 2 x to the power 7 by 2 minus 1, which is 5 by 2. If I simplify this, I'll get half x to the power minus 5, or 1 by 2 x to the power 5 plus x to the power 5 by 2, or the square root of the fifth power of x. Oh, this was minus 7 by 2, not positive since this was in the denominator. So this will be minus 7 by 2 x to the power minus 7 by 2 minus 1, which is minus 9 by 2. This term over here will be minus 1 by x to the power 9, and we take the root over of that. Now for A2, we have to explain why 0.25 cannot be used as an initial approximation in the Newton-Raphson process. So the formula for the Newton-Raphson process is, here our n plus 1th approximate will be the value of the previous approximation minus f of that approximation value, so this value, divided by the derivative of the function at that value. So this is the Newton-Raphson processes method. Now for 0.25, if I have f prime 0.25, I put 0.25 in this equation, 1 by 2 to the power 0.25 to the power 5, this is 512, minus 1 by root over 0.25 to the power 9, this is also 512, so this becomes 0. Now if I look into the formula, f prime x is in the denominator, so I'll have f of x divided by 0. This does not, we cannot divide by 0, so since this is 0, the process cannot be carried out, as it would require a division by 0, which is not possible. So that's how we answered this. Now we'll take 0.15 as our first approximation to apply the Newton-Raphson process. And I have to find the second approximation to alpha. So alpha is the second approximation, is the first value, which is 0.15 minus f of 0.15 divided by f prime of 0.15. If I calculate them, f of 0.15 is basically placing 0.15 over here. If I calculate that, this value comes out to be minus 27.33250956, and f prime 0.15 is basically placing 0.15 in this equation. If I calculate that, I'll get 1484.137157. Use as many decimal places your calculator can go to. So alpha is 0.15 minus 27.33250956 divided by 1484.1371. If I calculate this to the nearest 3 decimal places over here, I'll get a value of 0.168. Now for the next question, we have to use linear interpolation once in this interval over here to find another approximation to alpha. So I'll sketch it out. At 0.15, the value of f of x, or f of 0.15, is minus 27.332500956. So this length over here is 27.332500956. The graph goes like this. This over here is the root alpha. This is 0.25. This is the interval we are given. And this height over here is f of 0.25. So basically putting in the value 0.25 in this equation. If I do that, I'll get a value of 39/7 exactly. And then we'll use the fact that this triangle over here and this triangle over here are similar, since this angle and this angle are equal. Both of this angle are 90 degrees, so the third angle must also be the same. So they are similar triangles. So the base of this triangle over here on the right, so I'll have this triangle marked blue and this triangle marked red. So for the blue triangle, the base is 0.25 minus alpha, the height is 39 by 7, and for the red triangle, the base is alpha minus 0.15, the height is 27.332.50956. I'll cross multiply. I'll have 39 by 7 times alpha minus 0.15 equals to 27.332.50956 times 0.25 minus alpha. I'll have 39 by 7 alpha minus 39 by 7 into 0.15 or minus 117 by 140. And on the right side, I'll have 6.83312739 minus 27.332.50956 alpha. It's not necessary to keep so many decimal places since our question asks us the answer to 3 decimal places. I can keep it to 4 decimal places and ignore the rest. That would make calculations easier. Now I can find out alpha by simple rearrangement. 36 by 7 alpha. I'll send it to the right. So in this side I have minus 6 point. No, I'll just bring it to the left. Okay. So I'll have 39 by 7 alpha plus 27.332.50956 alpha equals to 6.83312739 plus 117 by 140. From here I can find alpha. This will be equal to this term over here divided by 39 by 7 plus 27.332.50956. From here the value of alpha to 3 decimal places will come out to be 0.233. Now moving to question 5. We have this quadratic equation given where k is an integer and we are given the roots at alpha and beta. We have to find the value of alpha plus beta and the value of alpha beta. Now we know that any quadratic is given in this form. So x square minus the sum of roots times x plus the product of root. This is equal to 0. This is how a quadratic equation with the roots are given, where this is the sum of root, this is the product of root. Here alpha and beta are the roots, so the sum of root is alpha plus beta, the product of root is alpha times beta. Now slight issue over here, it doesn't begin with an x square, so I have to divide everything with 4. So I'll get x square plus 3 by 4x plus k by 4 equals to 0. So alpha plus beta is minus 3 by 4. We have to bring this minus over here, which is commonly missed out since the equation is x square minus sum of root x. You have to notice that there is a minus over here, but there's a plus over here. So the sum of root must be negative. It must be minus 3 by 4, and alpha beta will simply be k by 4. Now for part B, we are asked to find in the simplest form and in terms of k the value of this. So alpha by beta square plus beta by alpha square. we can take a common denominator of alpha square beta square. Here we'll have alpha cube plus beta cube. Basically alpha times alpha square plus beta times beta square. We'll have alpha cube plus beta cube. Now we have to remember that this thing over here, so alpha cube plus beta cube, can be written as alpha plus beta whole cube minus 3 alpha beta times alpha plus beta. You have to remember this over here. If we continue with that, I'm doing this since I don't know the value of alpha cube plus beta cube directly, but I know the value of alpha plus beta and the value of alpha beta. I can write this thing over here as alpha plus beta whole cube minus 3 alpha beta multiplied by alpha plus beta. The whole thing is divided by alpha beta cube, square, alpha beta square. This is because a term like 2 cube times 4 square can basically be written as 2 times 4 the same power. So 2 to the power cube times 4 to the power cube, 2 cube into 4 cube can be written as 2 times 4 whole cube. If you calculate this, you'll see the left hand side and right hand side are equal. So basically we're using that to convert this into this. Now I'll just place the known values of alpha plus beta and alpha beta. I'll have minus 3 by 4 cube minus 3 times k by 4 times minus 3 by 4 divided by k by 4 square. Minus 3 by 4 cube is minus 27 by 64 and minus 3k by 4 times minus 3 by 4 is plus 9 by 16k, and in the denominator we'll have k square by 16. This term over here as 9k times 4, so we are basically taking 64 as the common denominator on the top. We can write it as 9k times 4 minus 27 all divided by 64 divided by k square by 16. I can write k square by 16 over here as this, and then I can cancel 16 and 64 since 16 times 4 is 64. I'll get this term over here for the answer to part B. Now for part C, we have to find the quadratic equation with the roots alpha by beta square and beta by alpha square. The sum of root in this case will be this term over here, alpha by beta square plus beta by alpha square. So that is the sum of root in this case. So this is the sum of root, and the product of root will be alpha by beta square times beta by alpha square. We can cancel out the beta and the alpha. So I'll basically get 1 by alpha beta. The value of alpha beta is k by 4. I can just place it there. And from that I'll get the value of the product of root, which is 4 by k. Product of root, which is 4 by k, and the sum of root, which is 36k minus 27 divided by 4k square. So I can write the quadratic equation in this form. So x square minus the sum of root times x plus the product of root, this is equal to 0. I have x square minus 36k minus 27 divided by 4k square plus 4 by k equals to 0. Now I cannot keep it in this form since they want us to give the answer in integer multiples of k. So I can multiply both sides with 4k square to get rid of this. By doing so, I'll also get rid of this. So I have 4k square x square. Then I have minus 36k minus 27 times x, and 4 by k times 4k square is 16k equals to 0. This is the answer. Now moving on to question 6. Question 6 is about a hyperbola. We are given the equation of the hyperbola with xy equals to 20, and we are given a general point with this equation. Now if you look at the data booklet, we'll find that the general point on the hyperbola is ct comma c by t, where xy is equals to c square. So c will be root over 20 or 2 root 5. Now if I look closely, if I remove the t, I'm left with 2 root a. This can be compared with 2 root 5 over here. Also, if I remove the t over here, we have c by t. So the top is c. So 2 root 5 over here. So in this case, the value of a is 5. Now we have to show that the normal to the hyperbola at point P has this equation over here. For this, we need the gradient. The gradient of the tangent, we can get the gradient of the tangent by differentiating this equation. So at first I'll move the x to the right. I'll have 20 by x, which is x to the power minus 1. If I differentiate this, I'll get minus 20 x to the power minus 2 or minus 20 by x square. This is the gradient of the tangent. Now I know the x coordinate of P. This is 2t root a. I have to square it. So the gradient of the tangent is minus 20 divided by a is 5. So 2 root 5 whole square, which is 20. And we have t square over here. This is the gradient of the tangent. This is minus 1 by t square. Now we know that the normal will be perpendicular to the tangent. So if I multiply their gradients, it will be minus 1. So gradient of the normal will be minus 1 divided by the gradient of the tangent, which is minus 1 divided by minus 1 by t square, which is positive t square. Now we can use the equation which will be y minus y1 equals to the gradient of normal x minus x1. The value of y1 is 2 root 5 by t. The gradient is t square, and I have x minus x1, which is 2t root 5. Now I can just rearrange this to find the equation. I have a t in front of y, so I'll multiply both sides with t. I'll get ty minus 2 root 5 is equals to t cube x minus 2t to the power 4 root 5. We can write that down as, now we can move everything to the left. I have ty minus 2 root 5 minus t cube x plus 2t to the power 4 root 5 equals to 0. So I'll I can take 2 root 5 common between these two. I'll have ty minus t cube x plus 2 root 5 since there is a minus in the show, I'll take minus 2 root 5, then this will become positive 1 and this will become negative t to the power 4 equals to 0, and this is what we had to show. So this is it for this question, this part of the question. Now in part C, we are given points A and B which lie on the hyperbola. Point A has a parameter t equals to c, while point B has a parameter minus 1 by 2c, where c is a constant. Now we are told that the normal to h at A meets h again at B. So at h, the normal at A, where t is equals to c. So we can rearrange this equation to be cy minus c cube, sorry, my bad, cy minus c cube x minus 2 root 5 1 minus c to the power 4 is equals to 0, and this will pass through B. Now for B, the value of t is minus 1 by 2c, so the point B has coordinates 2 times minus 1 by 2c root over 5 comma 2 root 5 divided by minus 1 by 2c. This will come out to be minus root 5 by c and minus 4c root 5. So we can take this down. Now this normal over here will pass through this point over here, so I can place the value of y and x in there. So in place of y, I'll put in minus 4c root 5. So c times minus 4c root 5 minus c cube times minus root 5 by c minus 2 root 5 1 minus c to the power 4 is equals to 0. I'll have minus 4c square root 5 minus, sorry, this will minus minus, so it will become positive, so plus root over 5 c square root 5, then we have minus 2 root 5 plus 2 root 5 c to the power 4 or 2c to the power 4 root 5 equals to 0. We can multiply the whole thing with root 5 to get rid of it, since since we have root 5, sorry, we will divide both sides with root 5. So we'll get rid of the root 5s, so we get minus 4c square plus c square minus 2 root 5 by root 5, so this is minus 2, and we have 2c to the power 4. So we can solve this like a quadratic. So we have 2c to the power 4 minus 3c square minus 2 is equals to 0. We can directly solve this like a quadratic, or we can take another step. We can change it to another variable, call it anything p, which is c square. P hasn't been used yet in this question. Yeah, we need to check that this variable that we are naming over here was not used in the question before or after this. So we have 2p square minus 3p minus 2 is equals to 0. So this is a quadratic which we can solve quite easily. We can break this down with middle term. So we'll have 2p square minus 4p plus p minus 2 is equals to 0. 2p p minus 2 plus 1 p minus 2 is equals to 0. So from here we get the value of p to be 2 and p to be minus half. P is also equal to c square, so c square is 2 or c square is minus half. So c is plus or minus root 2 or c is plus or minus root minus half. So c can only be these two values over here. C can only be plus minus root 2 and not root over minus half, since c square has to be greater than 0 in this question. We are given, so over here we are not taking this over here, because in this question c square must be greater than 0. So we'll move on. Now question 7 is about a matrix. We have matrix P given over here, 0 minus 1 minus 1 0. In the first question we have to describe the geometric transformation that P causes. This over here is for the reflection in the line y equals to minus x. We'll write that down. Reflection in the line y equals to minus x. Now we are given transformation V, which is represented by the matrix Q, which is a rotation of 240 degree anti-clockwise about the origin, followed by enlargement with scale factor 6. We have to determine this. We know that for any rotation we have this matrix cos theta minus sin theta cos theta, where theta is anti-clockwise rotation about origin. For this case we have 240 degrees of rotation anti-clockwise, so cos 240 degree minus sine 240 degree, sine 240 degree, cos 240 degree. And since we have a enlargement with scale factor 6, we can multiply a 6 over here, or we can take it as this vector over here. This is the vector for the this is the matrix for the enlargement with scale factor 6. Can just take a 6 over here. We'll get minus 3 root 3 minus 3 root 3 and minus 3. With the 6 inside multiplied, we get this. This is the matrix Q. Now for question C, we are given that U followed by V is the transformation T, which is represented by matrix R. We have to find matrix R. So U is followed by V. U is matrix P and V is matrix Q. So for a note, we can note down that A followed by B is represented by the A on the right, B on the left. So in this case, we need the vector QP over here. So matrix R is Q times P. The matrix Q is minus 3, 3 root 3 minus 3 root 3 minus 3. And the matrix P is 0 minus 1 minus 1 0. Now we have to do the matrix multiplication for this. We have minus 3 times 0 minus 1 times 3 root 3, so minus 3 root 3 over here. Next up we have minus 3 times minus 1, which is positive 3, plus 3 root 3 times 0, which is 0. Then for this term we have 0 times minus 3 root 3 plus minus 3 times minus 1, which is 3. And finally for the last term we have minus 3 root 3 times minus 1, so positive 3 root 3. This is the vector R. This is the matrix R. Now we are given part 2 of the question, where transformation W is represented by this matrix. We have to show that the real number lambda, for which W maps the point lambda comma 1 onto 4 lambda comma 4, we have to find the value of lambda. So if I multiply this vector with lambda 1, we get 4 lambda 4. I have to solve this matrix multiplication. So on the left we have minus 2 times lambda plus 2 root 3. So minus 2 lambda plus 2 root 3, and over here we'll have 2 lambda root 3 plus 2. This will be equals to 4 lambda by and 4. We can solve this now. We have 2 lambda plus 2 root 3 is equals to 4 lambda. So 6 lambda will be equal to 2 root 3. And lambda will be equal to root 3 by 3. And if we look at the other equation, we have 2 lambda root 3 plus 2 is equal to 4. We have 2 lambda root 3 equal to 2. Lambda equals to 2 by 2 root 3, which is root 3 by 3. We could use any of this, so we can compare the top or the bottom. And that's it for this question. Now we go to question number 8, which is a question about parabolas. We are told that line L1 is the line with equation y equals to k, where k is a positive constant, and we are given that this line intersects the parabola at point P, and we have to find the distance of point P from the focus S. We are told S is the focus as well. Now we know that the y value of the line is equal to k, so we can just put that over here. So k square is 4ax. We can find the x value as well, which is k square by 4a. So for the point P, the coordinates are k square by 4a comma k. Now to find the distance PS, we can draw a sketch. The focus S is at a comma 0, and this is point P, which is k square by 4a comma k. We have to find the length of this black line over here. we have PS square. This will be equal to k square by 4a minus a whole square plus k whole square. So PS square will be equal to k to the power 4 by 16a square minus half or minus 2 times k square by 4a times a plus a square. This is k to the power 4 by 16a square minus k square by 2a plus, we'll have a plus k square as well. So plus a square plus k square. Now we can separate them in terms of k. We'll have k to the power 4 by 16a square minus, we can take a common denominator of 2a over here. We'll have k square by 2a and plus 2a k square plus a square. Now we can take 16a square to be the common denominator of this term. So if we do that, we'll have 16a square over here, k to the power 4 minus, now we have to multiply this with 8a. So we multiply this with 8a since we get 16a square if we multiply 2a with 8a. So minus 8a k square plus 16a square k square plus 16a to the power 4. Now for finding PS, this was PS square. To get this into PS, we'll have to square root it. Now we can find the square root of the denominator quite easily. This is 4a, and for the numerator it's k to the power 4 minus, we'll have an a over here as well. So this will be 8a square k square. So this is k to the power 4 8a square k square plus 16a to the power 4. This can be written as k square plus 4a square whole square. So if we do that, we get root over whole square of k square plus 4a square and a 4a in the denominator. The root over and the square root will cancel out, leaving us with k square plus 4a square divided by 4a. This is what we had to show. Now for part B, where we have to show that the y coordinate of A is this expression over here. Now we are given the details. So the line L2 passes P and intersects the directrix on the x-axis, and line 2 intersects the y-axis at point A. We have to find the y coordinate of that point. Now to do that, we can find the equation of line L2 at first. To do that, we have this shape over here. This is the directrix, this is the line, and this is the parabola over here. Now the gradient will be the y value divided by the x value. The change in the change in y value will be k. The change in x value will be equal to ps. Since we know that this distance over here, the distance from the focus will be the distance to the directrix for a parabola. So that would be 4a square k. That will be k square plus 4a square divided by 4a. So the gradient will be 4ak divided by k square plus 4a square. Now the directrix has the equation of x equals to minus a, y equals to 0. Now we'll use this fact over here. We know the gradient, we know y1 and x1. I can just put it over here. I'll get y minus the y value over here, which is 0, which is equal to the gradient, which is 4ak divided by k square plus 4a square multiplied by x minus x1, which is minus a, so x plus a. And now using this equation, I want to find when x equals to 0 the value of y. So we can set x equals to 0, we'll get y equal to 4ak k square plus 4a square 0 plus a, so just multiply a, we get 4a square k x. And that's it for the show. We have shown that. Now for the next part of this, we are given line L1 which intersects the directrix of the parabola at point B, and we are given the areas of triangle BPA and OSP and the ratio of that area, which is 4k square is to 1. We have to find the exact value of A. To do so, I have the area of triangle OSP. So for a parabola like this, this is the origin, S is over here and P is over here, this triangle. The area of this will be half into AK, and the area of BPA will be half times k square plus 4a square by 4a multiplied by k minus 4a square k and k square plus 4a square here. Now we can use the ratio of areas. We get k square, we can just write this down, have k minus 4a square k divided by k square plus 4a square divided by ak is equal to 4k square. From here we need to find, this was a half over here, so I can just place the half inside. So this was half, I can place the half over here and have 8 in the denominator. Now I need the area of the ratio of the areas BPA by OSP, but before that I'll simplify the area for BPA. I have k square plus 4a square divided by 8a multiplied by, I'll turn this into one single expression with the same denominators. So I'll have k times k square plus 4a square minus 4a square k, and then we multiply both. I have 8a times k square plus 4a square. We have k square plus 4a square here as well, multiplied by k cube plus 4k k cube plus 4a square k minus 4a square k. So these two cancels out. I'm left with k cube multiplied by k square plus 4a square divided by 8a k square plus 4a square. I can cancel these out. I'll be left with k cube by 8a. Now if I want to find the ratio of the area, so area of BPA divided by area of OSP, I'll have k cube by 8a divided by half ak. So if I write this down, this can be written down as k cube by 8a multiplied by 2 by ak, and we are told that the ratio is in this form. So the area of BPA is 4k square times the area of OSP. So this expression over here will be equal to 4k square. We have 2k cube divided by 8a square k, which is equal to 4k square. We can cross multiply. We have 2k cube equals to 8 times 4. So we have 32 a square k cube. We can cancel out the k cube on both sides. We'll have 2 equals to 32 a square. From here we can find the value of a. A square is 2 by 32 or 1 by 16. So a is root over plus or minus 1 by 16, which is plus or minus 1 by 4. Now we are told in this case that a is a positive constant, so we don't have to take minus 1 by 4, so a is just 1 by 4. Now on to the last question, which is about proof by induction. For this we'll have to consider n equals to 1 at first. So for when n equals to 1, the summation of r equals to 1 to 1 of log 2r minus 1 will be log 2 times 1. So 2 log 2 minus 1, which is log 1. This is the left hand side, and the right hand side when n is 1 would be log 2n is 2, so 2 factorial divided by 2 to the power 1 times 1 factorial. So basically 2 times 1 factorial will have log 2 divided by 2, which is log 1. So left hand side and right hand side are equal, both are 0 or log 1. We can just write both of them. So we can write that log 1 equals to log 1 or 0 equals to 0. We know left hand side is equal to right hand side when n equals to 1. Now we'll have to assume that it's true for n equals to k. So assuming it's true for n equals to k, so it's true for this term. So summation of r equals to 1 to k of log 2r minus 1 will be equal to log 2k factorial divided by 2 to the power k factorial. We'll bring it over here. Now for n equals to k plus 1, the summation will be the summation of this, so up to k, and then we'll add the k plus 1th term, so log 2k factorial divided by 2 to the power k factorial plus the k plus 1th term, which is log 2 times k plus 1 minus 1. We have log 2k factorial 2 to the power k factorial plus log 2k, and we have plus 2 minus 1, so 2k plus 1. Since they are both logarithms with the same base, we can bring it inside over here as a multiplication. I'll have 2k factorial times 2k plus 1 divided by 2 to the power k factorial. Now we can write the top, so 2k factorial multiplied by 2k plus 1 is basically 2k plus 1 factorial. We can see this as an example. So if 2k was 10 and I multiplied 2k plus 1, which is 11, so 10 factorial into 11. This is basically 11 factorial, since we have 11 into 10 factorial, which is 10 into 9 into 8, so on and so on. This is 11 factorial. So we have log 2k plus 1 factorial divided by 2 to the power k times k factorial. Now to show that the equation is valid for k plus 1, we must have something where we have 2k plus 1 and the factorial of this divided by 2 to the power k plus 1 times k plus 1 factorial. Now if I look at the top, I have 2k plus 1 factorial. However, if I wanted to convert this into 2 times k plus 1, I'll basically need 2k plus 2 factorial. And to do that, I can just multiply 2k plus 2 on the top and bottom. So I multiply 2k plus 2 on the top and on the bottom. So on the top, I'll get 2k plus 2 factorial. And on the bottom, I have 2 to the power k times k factorial multiplied by 2k. I can basically write 2k plus 2 as 2 times k plus 1. Now k plus 1 times k factorial is basically k plus 1 factorial. So if I continue with this, I have 2 times k plus 1 factorial on the top, and on the bottom we have 2 to the power k times k factorial times k plus 1 is k plus 1 factorial, and I'm left with a 2 at the end, so this 2. This is 2 to the power 1, so I can write down 2 to the power k times 2 to the power 1 times k plus 1 factorial. Now we know by the law of indices that a to the power m multiplied by a to the power n is basically a to the power m plus n. So on the top we'll have 2 times k plus 1 factorial divided by 2 to the power k plus 1 times k plus 1 factorial. So if it's true for n equals to k, it will also be true for n equals to k plus 1. Since it's true for 1, it will be true for all integers, all positive integers. This is how we write down our answer. We talk about how if it is true for n equals to k, it must also be true for n equals to k plus 1. And if it's true for 1, it will also be true for 2. If it's true for 2, it will be true for 3. So if we go on and on, it must be true for all positive integers. And that's it for this paper.